Okay, last class I showed you how to use our new equation for the force on a moving charge in a magnetic field for an example that just had a real simple velocity and magnetic field. We saw you could just use the right-hand rule and cross-product relationship to figure out the answer. But if you have a more complicated 3D example like I have here, it's a little more complicated to do using just the right-hand rule. For instance, if this is my x, y, z coordinate system here, my velocity vector goes over 2, down 3, and out 2. So it's a vector pointing kind of that way. The magnetic field vector goes over 3, up 2, out 5. So it's a vector pointing up this way. So I got a v vector that points that way and a magnetic field vector that points kind of this way. So if I do the cross product between those, the right-hand rule, I point my fingers in the direction of v, I curl towards b, I get a thumb that points kind of that way. So maybe that has a negative x component, possibly a negative y component, and possibly a positive z component for the answer. But it's difficult to do that in 3D to tell exactly where your thumb's going. So we need to figure out a way to do this mathematically. To do this mathematically, we need to solve a 3x3 determinant. So first, notice all the units are SI units, Tesla, meters per second, coulombs. So the answer could come out in newtons, so I'm just going to write 1 newton here. Then I write a 3x3 determinant where I write ijk across the top row. Then I put the components of the first vector v next. So I have a 2, a negative 3, and a 2 for the components of v. Then I write the components of the next vector, 3, 2, and 5. Now I need to solve this 3x3 determinant. So to do that, I first cross out the first column and first row. What gets crossed out twice is the I, so I write an I down. And what's left are these 4 numbers. We need to solve this. This is a 2x2 determinant. To solve determinants of this type, you go this times this minus this times that. So I'm going to have a negative 3 times 5 minus 2 times 2. It's just how we solve 2x2 determinants. Okay, then I need to cross out the middle column, top row. So I need to do the 2x2 determinant with these 4 numbers, which are not crossed out anymore. But when you cross out the j term, you got to put a minus sign in front of it because it's just the way it works out mathematically when you do the term-by-term multiplication and do the cross product. You end up with a negative j term. So write a negative j, and then I have a 2x2 determinant. So 2 times 5 minus 2 times 3. Okay, then I need to cross out the last column, the k column, and like the I term, it is positive, so I write a plus k, and I'm left with these 4 numbers. So I have a 2 times 2 minus a minus 3 times 3. Okay, then I can simplify all the math. I got negative 15 minus 4, that's minus 19i. I have 10 minus 6, so 10 minus 6 is 4, but there's a minus j in front, so that's negative 4j. And I have 4 plus 9, that's 13k. And this should be in newtons. So that's the mathematical answer for the force. And it does kind of agree with what I predicted earlier when I did the v curl towards b. I expected a negative x component, a negative y component, and a positive z component. But this is the way to do it mathematically. Oh yeah, and you could expect one of these on your test.